Hey, what's up, people? We are back again with some more homework content. This is day 9, 21 days challenge of blockchain fundamentals. 4 sections. Section number 1, homework on replay attacks. 2 questions. Question number 1, Lego. Why do we have to worry about replay attacks when hard forking a blockchain? Well, when a hard fork is actually just a copy of an original forked blockchain. So a hard fork is a copy. So all previous transactions will exist on this new chain as well. So signed transaction on the other blockchains, like on the original blockchain, could be replayed on the let me put it this way. Signed transaction on the forked blockchain could be replayed on the original blockchain, since this chain is a fork, is a copy of the original. So all the characteristics are the same. So everything that would be done there would just be deemed as valid, since the keys are the same. Question number 2: how can a hard fork protect its users from replay attacks? Well, actually, there are two ways. There are two main ways of protecting yourself. So you have to apply change in the transaction. So there are two ways of doing that. So just by applying change within the transaction, this is how you protect yourself. So the first way, they call it it's called strong two-way replay protection. So this just means that you have to make sure that transaction from the original blockchain can never be valid on the copy. And the second way is opt-in replay protection. So this means that your transactions are always going to be exposed to a replay attack unless you manipulate your transaction in a way that it makes it invalid. It makes it invalid for you to use this information on the other blockchain. So actually, there are two ways that I look at this. So a strong two-way, this can be done. This is something that can be done within the fork. Like when you're forking, you do this, you implement this change so that everybody is protected. The opt-in, this is actually something that the user has the choice to do himself. So this is the way I look at it. So moving on to homework on Bitcoin attacks. 2 questions. Question number 1, we're back again. What happens in the 51 attack? I remembered some days ago we talked about 51 attack. So for me to come back on this, so 51 attack is basically just a group of nodes that gather enough hash power to become the majority hashing power holder in the network. So once this is done, they start creating invalid blocks, and these invalid blocks are separate from the main valid blocks in the blockchain. But since they have the majority of the hashing power, eventually these invalid blocks will become longer, and since you know that the longest chain always win, this is how this is how they can perform a 51% attack, because they have the majority of the votes, they have the majority of the nodes. This is why their invalid blocks is going to become the valid blocks in a way, in the matter of speaking. So just because they have more power, so eventually their chain will become longer. Question number 2: why is it unlikely that someone will attempt a 51% attack? Well, think about it. A 51% attack means you have to, this is just, it just says, for me, I just see it like this: it's going to be very expensive, because proof of work means you have to, if you think about what we just said all the previous days, proof of work means you have to invest something. So you have to invest electricity, you have to invest equipment. So this is very, very costly. Yeah, so you have to invest electricity, equipment, in order to gain the majority nodes within the network. And not only that, but once you succeed and all the essentially valid blocks become invalid, this will also make sure that the network is not more trustworthy. So the value of the blockchain, or the value of Bitcoin in this case, is going to drop, because nobody can trust the network anymore, since it has been subjected to a 51% attack. Actually, if you look at CoinMarketCap, try to check, like for example Verge or all these other currencies that has been subjected to attacks, you always see that their value also drops. Like even if it's a short period of time, their value always drops, because when somebody hears like this network has been hacked or something, then people are like panicking, and they try to take out their funds as fast as possible, causing the value of the network, or of the value of the coin, to go down. But we're gonna talk about coins in another section. Let's just focus on the fundamentals. So the third part, homework on Byzantium fault tolerance. So for this part, I'm gonna head over to the board. There are two questions. Let me just give the questions. What is a Byzantine general's problem? And the second question is, how is a Byzantine general problem interesting for a system like Bitcoin? So in order for me to answer these questions, I'm gonna head over to the board. See you in 3 seconds. Yes, so basically for this story, what happens? Like, you have a fortress, right? And you have one general here. My drawing skills are not of the best. So let's say you have General 1, General 2, General 3, and General 4, right? So you have these generals, they all plan to attack this fortress, right? But because of the geographical location, they have to come into consensus, into agreement of when is the right time to attack. But of course, what are the problems they're facing? First of all, let's say they have to attack, let's say at dawn, right? They have to attack at dawn. Now, how do they agree upon attacking at dawn? So General 1, for example, will have to send message to General 3, and in turn he would have to communicate also with General 4, and also vice versa. This is how the communication will have to run. Or he can send message, like he can send a messenger to each and every one. But not only that, what also needs to happen is that after each and every one of the generals, after they receive the message, they have to comply back. They have to like give an agreement back, like, okay, this is what has been agreed upon. But now here lies the problem. How do they all know that the information? How do they all know that the information is valid? How? There is no way, because if this general sends a messenger here, maybe the messenger can be captured, maybe the information that is being sent back, maybe they don't agree, but maybe they are a traitor or something, and they send back another information. Or maybe they can say yes, it's good, but they say something else to this general. So there's actually no way for you to, like in this problem, there is no way for you to know 100% of a certain that yes, this is what we agree upon. We attack at dawn, and everybody is like 100% okay with that. So now, why is this story of importance to the Bitcoin network? Well, actually, the Bitcoin network, it's almost the same, because okay, let's say you have your miners, right? You have your miners. Let me just say you have miners. Are all nodes, and all this, right? All this represents the Bitcoin network. Yeah. Let's just say this is a Bitcoin network. Yes. So now, in this network, everybody has to play nice, right? So how do they all come into consensus? How do they all come into consensus? Well, they come into consensus by investing. Like, let me say, all the miners, they are incentivized to invest electricity, right? Not only that, but they also have to spend on hardware, because they have value, right? All this is equal to value. So this is their stake. This is what this is the value they bring to the network. So for the miners now, it costs them electricity to mine, to be a miner. And in order for you to be able to mine, you have to have the right equipment. So you have to invest financially in your hardware, and you have to invest electricity in order to mine. So this is the cost. So for them, it's a value. So they are incentivized to play nice within the network, because now, if a miner is trying to disrupt the network, well, the block that this miner is producing, if it's a bad block, right? Bad block. If it's a bad block, the network is going to disregard this network, and they don't get paid, because we all know miners, they get paid in like in the case of Bitcoin, they get paid in Bitcoins. Let me just say BTC, and those are like the fees, right? So if a miner is producing a bad block, right, they don't get paid. And why is this not good for a miner? Well, the miner has invested money in hardware and electricity. So if you're not getting compensated for this investment, it's a bad business. So that's why it's very important for miners to play nice in this scenario. And this is why this like, you can also compare this to that story that we just told, because it's a little bit similar. And by applying the proof of work concept, this is actually a way, I'm not saying it's the best way, but this is a way of solving the problem. As you're gonna see in the upcoming days, we're gonna talk about different ways of approaching these problems. But for now, this is how the proof of work concept works. Okay, up to the next, to the last section, and I'm gonna switch location. See you in some few seconds. Okay, for the final part, we have homework on importance of mining. So here we have two questions. Question number one, what is hash rate? Well, hash rate is actually just attempts per second made in order to guess a correct nonce when mining. Question number two, what is the danger of a few nodes gathering a lot of hash rate? Well, this is equal to less decentralization and more risk of a 51% attack. So when you have a few nodes gathering a lot of hash rates, yeah, this just means that the power is being centralized within a small group of nodes of people or people, and this is where this risk of 51% attack that we just talked about is being created. So those were my answers for today's topics. So today, as I said, we had four. I know I keep saying six. We had four main topics today. We touched replay attacks, we touched Bitcoin attacks, we touched the Byzantium fault tolerance on the board, and we also touched the importance of mining. I hope everything was clear. If there is any additional information that you think is relevant and you want to share it, please kindly do so in the comments. If there was something that I explained that wasn't correct or was partially correct, please kindly comment down below and let us know. Let me know. We're all here to learn. And if you like to know more about blockchain fundamentals, I highly suggest you to take the courses of Ivanontec. He does a great job at explaining everything. This is just me going even deeper within the courses. So that was it for today. I hope to see you on day 10 tomorrow. Things are rolling, so see you at day 10. Victorious Victor checking out. See you at day 10. I'm out. Yo.